Now, the method of completing the square, which we learned in the preceding videotape, is a very nice method. It always works. It will always give you the solutions for a quadratic equation. The only problem is that it can get sort of messy, especially if fractions are involved. One of the important uses of this method of completing the square, however, is that it enables us to derive a formula for solving quadratic equations, which always works, and usually works a lot nicer, a lot neater than the method of completing the square. And we're not going to go through the derivation here. Let me just say that if you have a quadratic equation in standard form, ax squared plus bx plus c equals 0, where we assume that a, of course, is not 0, or else it wouldn't be a quadratic equation, the method of completing the square will enable us to derive the following formula for the solutions to this quadratic equation. The solutions are given by the formula x equals minus b plus and minus the square root of b squared minus 4ac, all divided by 2a. You should know this formula like you know your name. Okay, this is a very important formula. You must commit it to memory. You must know it without anything. You just have to know it cold. Okay, it's very important for you. Now notice that this is giving us two solutions for x. We have minus b plus and minus the square root of b squared minus 4ac over 2a. Okay, we substitute into the formula, and we take minus b plus the square root over 2a, that's one solution, minus b minus the square root here over 2a, that's the other solution. Now, in an earlier videotape, I mentioned that a quadratic equation can have at most two real solutions. Now, this goes along with that. If b squared minus 4ac is a positive number, okay, we can take the square root. Okay, we will have a positive number here. It may not be rational, okay? But we have minus b plus that, minus b minus that. Each time dividing by 2a, we get two real solutions. On the other hand, if b squared minus 4ac comes out to be 0, the square root drops out. We get minus b plus and minus 0. That's just minus b over 2a, one real solution. If b squared minus 4ac comes out to be negative, we cannot take the square root of a negative number. The square root of a negative number is not a real number, and therefore we would get no real solutions to the quadratic equation. So this is in line with what I mentioned earlier, that a quadratic equation can have at most two real solutions. Okay, now let's use this formula to solve quadratic equations. Let's start with the example 2x squared minus 3x equals 6. Now, if you look at the formula over here, we must start with a quadratic equation in standard position. That is, everything on one side equals 0. Okay? The right-hand side must be 0. In this case, we have 6. Before we can use the formula, it must be exactly in this form. So we're going to subtract 6 from both sides of the equation, giving us 2x squared minus 3x minus 6 equals 0. We now have this matching up to ax squared plus bx plus c equals 0. And it's a good idea to write the standard quadratic equation right underneath, because what we have to do is to figure out what a, b, and c are before we start the problem. Our aim is to substitute into this equation over here, okay, into this formula here. We must first know what a, b, and c are. So it's a good idea to stop first and actually write down a equals, b equals, c equals. Okay, a is the coefficient of x squared. Okay, the coefficient of the quadratic term. Here we see a is equal to 2. b is the coefficient of the x term, or the first degree term. Okay, with the sign, here we have b is minus 3. And c is the constant term. When we have the equation, the quadratic equation in standard form, we have the constant here, c is equal to minus 6. Okay, and don't forget to include the signs, okay, in a, b, and c. a is plus 2, b is minus 3, c is minus 6. Now we're going to substitute into our formula. X is equal to minus b plus and minus the square root of b squared minus 4ac divided by 2a. This gives us now A is 2, B is minus 3, C is minus 6. Minus B. Minus B, B is minus 3, plus and minus the square root of B squared. B is minus 3 squared minus 4. A is 2. C is minus 6. All divided by 2A, A being 2. All I have done is gone through this formula, substituting A is equal to 2, B is equal to minus 3, C is equal to minus 6. And now we will simplify. Minus a minus 3, that's plus 3. Plus and minus the square root of, now, minus 3 squared, minus 3 times minus 3, that's plus 9. Minus 4 times 2, that's minus 8, times minus 6, that's plus 48, all over 2 times 2, which is 4. Once again, this is 9. Minus 8 times minus 6 is plus 48, giving us x equals 3 plus and minus the square root. 9 plus 48, that's 57, all over 4. Now, there are two solutions to this problem. We have 3, okay, x equals 3 plus the square root of 57 over 4, and x equals 3 minus the square root of 57 over 4. The quadratic formula gives it to us in this compact form. Okay, but there are two solutions here. Here they are. 3 plus and minus the square root of 57 over 4. Now, don't be upset about the square root of 57 business. The square root of 57 is a number between 7 and 8. You see, 7 squared, that's 49. 8 squared is 64. The square root of 57 is someplace in between 7 and 8. It's about 7.5. Okay? So although this is not a rational number, okay, it is still a real number. It's 3 plus something around 7.5 over 4. 3 minus something around 7.5 over 4. Okay, so these are two real numbers. We have two real solutions to this quadratic equation. Let's try another example. X squared over 2 plus x over 5 equals 1 over 10. X squared over 2 plus x over 5 equals 1/10. Okay, now, this doesn't, at the first glance, it doesn't look like a quadratic equation in standard form. We're looking for something ax squared plus bx plus c equals 0. The fractions may upset you. And although it could be worked out in this way, I mean, you could let the coefficients of a, b, and c, the coefficients be fractions. It's much easier if you eliminate fractions on the first step. We're going to look for the lowest common denominator, multiply both sides of the equation by this lowest common denominator. In doing that, we will clear all fractions. It's a lot easier to work the problem in that way. Now, the denominators are 2, 5, and 10. The smallest number that they all go into evenly, they all divide evenly into, is 10. The lowest common denominator is 10. Okay, let's multiply both sides of the equation by 10. X squared over 2 plus x over 5 is to be multiplied by 10, and also 1/10 is to be multiplied by 10. Now we distribute the 10 through the parentheses. We get 10 x squared over 2 plus 10 times x over 5 equals 10 times 1/10, which is just 1. Remember, 10 is really 10 over 1. Okay, we just get 1 here. And the same thing here. This is 10 over 1 times x squared over 2, and so on. Now, the 2 goes into the 10 5 times, leaving you 5x squared plus 2x equals 1. Okay, now we almost have this in standard form with integer coefficients here. Let us subtract 1 from both sides of the equation. This gives us 5x squared plus 2x minus 1 equals 0. Okay, now we have it in the form ax squared plus bx plus c equals 0. We can solve it by the quadratic formula. Let's match it up. 5x squared plus 2x minus 1 equals 0. We're matching this up to ax squared plus bx plus c equals 0. And we get a equals 5, b equals 2, and c equals minus 1. A is the coefficient of x squared, 5, b the coefficient of x, 2, c the constant, which is minus 1. Now we substitute into the formula. X equals minus b plus and minus the square root of b squared minus 4ac over 2a. So we get minus b, that's minus 2, plus and minus the square root of b squared, that's 2 squared, minus 4, a, which is 5, c, which is minus 1, all divided by 2a, 2 times 5. So we get x equals minus 2 plus and minus the square root of, now, 2 squared, that's 4. Minus 4 times 5, that's minus 20, times minus 1 is plus 20 over 10. So we have x equals minus 2 plus and minus the square root of 4 plus 20, that's 24 over 10. Okay, now in this we can reduce a little bit. The square root here, this is not in simplest radical form. There is a perfect square factor under that radical. Okay, we can rewrite this as minus 2 plus and minus the square root of, now 24 is really 4 times 6. Trying to write it as a perfect square factor times something else, over 10. X is minus 2 plus and minus, now the square root of 4 times 6 is the square root of 4 times the square root of 6. This gives us minus 2 plus and minus, now the square root of 4, that's just 2. Minus 2 plus and minus 2 times the square root of 6 over 10. And we notice that there is a factor in common at top and bottom, namely 2. We can factor a 2 out on top, giving us 2 times minus 1 plus and minus the square root of 6. The bottom is 2 times 5. We can cancel the 2 on the top and the bottom, divide numerator and denominator by 2, giving us a final answer of minus 1 plus and minus the square root of 6 over 5. Remember, these are two roots. We have minus 1 plus the square root of 6 over 5 and minus 1 minus the square root of 6 over 5. Just going over what we did over here, we noticed that the square root of 24, this was not in simplest form. It had a perfect square factor. 24 is 4 times 6. We made it the square root of 4 times the square root of 6. The square root of 4 was 2. We still didn't have this in lowest terms since the numerator and the denominator had a 2 in common. We factored the 2 out on the top, the 2 out on the bottom, cancel the 2's, and then we get the answer. Okay, let's try another example. 3x squared minus 4x plus 1 equals 0. Here we have a quadratic equation in standard form. We match it to the ax squared plus bx plus c equals 0. And we see that a is equal to 3, b is equal to minus 4, c is equal to 1. We substitute into the quadratic formula, which is x equals minus b plus and minus the square root of b squared minus 4ac over 2a. And we get x equals minus b, that's minus a minus 4, plus and minus the square root of b squared, that's minus 4 squared, minus 4a C. A is equal to 3, C is equal to 1, all divided by 2A, 2 times 3. Don't forget, if B is negative, you really should have these parentheses. It's not necessary if B is positive. Okay, if B is 5, you just write minus B minus 5. But if B is negative, you should put parentheses here around the B and also over here. Okay, minus and minus 4, that gives you plus 4. Plus and minus the square root of, now, minus 4 squared, that's 16. Minus 12 over 6. We get x equals 4 plus and minus the square root of 4 over 6. X equals 4 plus and minus. Now notice in this case, okay, the number under the square root sign happens to be a perfect square. The square root of 4 just gives you 2. And we have this 4 plus and minus 2 over 6. Now there are two answers. We get x equals 4 plus 2 over 6, and x equals 4 minus 2 over 6. Now, 4 plus 2 over 6, that's 6 over 6. We get x equals 1. And over here, 4 minus 2 over 6, that's 2 over 6. Reducing to lowest terms, we get x equals 1/3. Okay, so we have solved this quadratic equation using the quadratic formula. Now, while the quadratic formula always works for you, it's not necessarily the easiest way to approach a problem. Okay, if in a problem, the number under the square root sign, okay, when you're working it out by the formula, the number under the square root sign comes out to be a perfect square. Okay, and therefore the square root drops out of the final answer. This means this was a kind of problem that could have been solved by factoring. If a problem can be solved by factoring, it's a lot easier to factor usually than to do it by any other method. Let me show you how we would solve this problem by factoring. A good idea usually to try factoring first, and if factoring doesn't work, if the problem can't be factored, or if you can't factor it, then to go on and do it by the quadratic formula. Okay, the example that we were working out was 3x squared minus 4x plus 1 equals 0. This factors very nicely into 3x minus 1 and x minus 1. There aren't many possibilities here. The first numbers have to multiply to 3x squared, so they have to be 3x and x, since 3 is prime. And the same thing with the last numbers. We have to multiply to plus 1. So either plus 1 and plus 1 or minus 1 and minus 1. And since the middle term here is minus 4, in other words, we want outer and inner, the minus 3x, the minus 1x, to give us minus 4x. Okay, we have really no other way to do it. This factors very nicely. 3x minus 1 times x minus 1 equals 0. You know that when we solve a problem by factoring, if you can factor it like this, setting it equal to 0, the product of two numbers is 0. That means, okay, either this number was 0 or that one was 0 or both. So we get 3x minus 1 equals 0 in one possibility, x minus 1 equals 0 the other. We solve these two first-degree equations. We get here, adding 1 to both sides, 3x equals 1, dividing both sides by 3, x equals 1/3. And here, adding 1 to both sides, x equals 1. You'll see that we get the same answers that we got before, the 1/3, and one with a lot less work. If a problem factors, then that is the easiest way to handle it. So the idea would be to always give a stab at factoring. Okay? If you can do it fairly simply, then by all means go ahead. This will be the easiest way. If for some reason you can't factor, or if the problem doesn't factor, those of course can be two different things. You could have a problem which factors that you just can't handle. Okay? Don't waste an inordinate amount of time on this. If after a while you can't factor, then move on and do it by the quadratic formula. It may take you a little longer, but the quadratic formula will always work for you. Okay? It took us quite a bit more work to get through this formula, but it did work. It gave us the correct answer. Okay? factoring is a lot easier if you can do it. Okay, you've just seen that in an example that factoring is a lot easier than doing it by the quadratic formula. Now, you'll recall there was another technique that we also learned for solving quadratic equations, and that was the method of completing the square. Okay, assuming a problem doesn't factor, so you can't do it that way, between the methods of completing the square and the quadratic formula, then the quadratic formula would be the easier way to handle it. Okay, let's look at this example. X squared minus 3x minus 5 equals 0. Okay, we try factoring, and we see that this does not work in this case. Okay, the question is which method to use here. Okay, so we try factoring, but it doesn't factor. We need two numbers which multiply to minus 5 and add to minus 3, and we can't do it. Try factoring. It doesn't factor over the integers. Okay, so that's out. Let's now try doing it by completing the square. Okay, the method of completing the square was taught in the preceding videotape. If you need to review it, you can, of course, go back and look at that tape. To do this by completing the square, okay, x squared minus 3x minus 5 equals 0. Let's add 5 to both sides, giving us x squared minus 3x equals 5. Okay, you see it's not in a form of a perfect square right now. To be a perfect square, the number here would have to be half of this coefficient squared. We need the square of half of this coefficient. Now, the coefficient is minus 3. Half of that is minus 3 halves. Squared, it's 9/4, and that's not what we have. So we move the constant that we do have over to the other side. We want the square of half of this coefficient. In the preceding videotape, we saw that a convenient way of doing that would be to set 2a equal to minus 3, solve for a, and then find a squared. This goes through the steps for you. 2a is minus 3, a is minus 3 halves. Half of this, a squared, is 9/4. Okay, a squared is equal to 9/4, and that is a quantity to be added to both sides. As I mentioned before, it is half of the coefficient of the first degree term, half of minus 3, which is minus 3 halves squared. We will therefore add 9/4 to both sides of this equation. Okay, this is just to help you figure out that the quantity to add is 9/4. Adding that, we get x squared minus 3x plus 9/4 equals 5 plus 9/4. The left side, of course, is a perfect square. That's why we went through this procedure to begin with. It's x minus 3 halves squared. It's x, and then half of this coefficient, quantity squared, half of minus 3 halves. This gives us now, we'd like to add 5 and 9/4. To add two fractions, they should have the same denominator. And we know that here we have the denominator 1, here we have the denominator 4. We combine over fourths, which is the lowest common denominator. 5 is equal to 24ths. We multiply the denominator by 4 to get the 4. We have to therefore multiply the numerator by 4 as well. We have x minus 3 halves squared equals 29/4. Then we take square roots of both sides, giving x minus 3 halves is plus and minus the square root of 29/4. Okay, x is equal to, now adding 3 halves to both sides. Okay, we add 3 halves to both sides, and we get x minus 3 halves plus 3 halves. It's just x equals 3 halves plus and minus the square root of 29/4. This is not, however, in simplest radical form, since we have a fraction under the radical sign. So we say that this is 3 halves plus and minus. Now we take the square root of the top over the square root of the bottom. The square root of the top, the square root of 29. The square root of the bottom, the square root of 4, that's 2. And we get 3 halves plus and minus the square root of 29 over 2. Okay, now let's try the same example using the quadratic formula. As I mentioned, it doesn't factor. We've done it by completing the square, and now we will do it by the quadratic formula. We take the original equation, which was x squared minus 3x minus 5 equals 0, and we match it to ax squared plus bx plus c equals 0, and we get a is equal to 1. If there is no explicitly written coefficient for the second degree term, of course, the 1 is implied here. A is 1, B is minus 3, C is minus 5. Okay, and we substitute into the formula minus x equals minus b plus and minus the square root of b squared minus 4ac over 2a. This gives us minus b, that's minus 3, use parentheses, plus and minus the square root of b squared, that's minus 3 squared, minus 4, a which is 1, c which is minus 5, all over 2a. This gives us x equals minus a minus 3, that's plus 3, plus and minus the square root of minus 3 squared, that's 9, minus 4 times 1, that's minus 4, times minus 5 is plus 20, over 2. We get x equals 3 plus and minus the square root of 29 all over 2, which same answers that we got by completing the square. Here are the other answers. You might note that when you do it by the quadratic formula, you get one fraction. In other words, you get 3 plus and minus the square root of 29 all over 2. This leads, of course, to the two solutions. 3 plus the square root of 29 over 2, 3 minus the square root of 29 over 2. The 3 halves plus and minus the square root of 29 over 2. Of course, these answers are equivalent, and I think that you will agree that the quadratic formula technique is certainly simpler than the method of completing the square. Okay, if, however, a problem factors, you should always try to factor first. If it factors, that is definitely the way to go. Factoring is easier than the formula, but as you can see, the formula is certainly easier than completing the square. And this brings us to the end of the tape.